A language model normally answers from memory, whatever it picked up during training. Retrieval-Augmented Generation hands it an open book instead. Before answering, it looks up relevant trusted information, then writes a response grounded in what it found. On their own, language models have real limits. Their knowledge is frozen at the time training ended, so they miss anything newer. They can't see your private or company documents, and when they are unsure, they'll often answer confidently anyway, hallucinating facts that sound right but simply aren't true. RAG's idea is refreshingly simple. Don't answer from memory alone. First, retrieve relevant facts from a trusted knowledge base. Then, augment the prompt with those facts, and only then generate the answer. Now, the response is grounded in real evidence and it can cite its sources. It helps to see RAG as two separate phases. Indexing happens once, offline. You turn your documents into a searchable knowledge base. Querying happens every time someone asks a question. Retrieve, augment, generate. Let's build that knowledge base first. Everything rests on embedding. An embedding model takes any piece of text and turns it into a vector, a single point in a space with hundreds of dimensions, positioned so that text with similar meanings land close together. Finance notes cluster in one region, HR policies in another. In this space, closeness literally means relevance. To index your data, you work through four steps. Chunk each document into small self-contained passages. Clean them and attach metadata like source and date. Embed every chunk into a vector and store those vectors together with their original text in a vector database built for fast similarity search. Do this once and you have a searchable store of the meaning. Now, a real question arrives. What was your Q4 revenue? We run it through very same embedding model we use for indexing. That turns the question into a query vector, living in exactly the same space as all the stored chunks. The vector database now compares that query vector against every chunk it has stored, scoring each one by how similar it is, most commonly using cosine similarity, essentially the angle between the two vectors. The chunks closest in meaning score highest. We just keep the top k, the small handful of passages most likely to contain the answer, and discard the rest. Those retrieved chunks are then stitched into the prompt, alongside a set of system instructions and the user's original question. And the instructions matter. Answer using only the provided context. Cite which chunk you used. And if the answer isn't there, say you don't know rather than guessing. Finally, the language model reads the augmented prompt and writes its answer, not from hazy memory, but from the evidence sitting right in front of it. It can point back to the exact source chunks as citations. The result is factual, traceable, up to date, and aware of your private data. Everything the plain model couldn't manage. Step back and compare. A plain model has static, frozen knowledge, hallucinates more often, and needs expensive retraining to learn anything new. A RAG system stays current simply by updating its index, grounds its answer in evidence, and can reach private data and show its sources. Generally more accurate and far cheaper to keep fresh. Production systems push this further. Hybrid search blends old-fashioned keyword matching with vector search. A re-ranker rescores the top hits using a heavier, more careful model. and entire families have emerged. Graph RAG over knowledge graph, agentic RAG where the model itself decides what to fetch, multimodal RAG over images and tables, and iterative retrieval that searches, reasons, and then searches again. RAG isn't magic, and it has failure modes too. Clumsy chunking can split an idea in half. Semantic chunking helps. Noisy retrieval drags in irrelevant text, so filter by metadata and re-rank helps. Too many chunks can overflow the context window. Compress and choose the top K wisely. And if answers still aren't grounded, tighten the prompt and demand citations. To sum it up, RAG turns a static, forgetful model into a dynamic and a trustworthy one, simply by connecting it to external knowledge. It already powers enterprise copilots, document Q&A, legal and healthcare research, customer support, and code assistance. Better answers, fewer hallucinations, and real-world impact. Thank you.